Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I'm going to continue with chapter number 5, that is optimizing program performance. Till now we have discussed about the topics like how to loop control or how to loop the unrolling, how to optimize or increase the performance of the computer or the program by incrementing or decrementing the program, or by into your next topic, that is understanding the modern processors. But before that, let's take a quick review what we have covered in the last class. This is so much hanging information. In the last class, we have discussed about the eliminating the loop inefficiency, that is how to eliminate the different loop efficiency, how to eliminate different loops or the different loop efficiency so that the program will be terminated or the program will be executed in a simplest way to increase the performance of the program. That is, you are eliminating the loop inefficiencies. In this, we have discussed multiple examples, like if we are using the same variable in the inner loop, if we are using the same variable in the outer loop. That makes a lots of difference between the inner loop and the outer loop. If I am using the inner loop, then the variable is only constant to only that loop only. But if I am using the global variable, that is common to everyone, that can be accessed by anyone. Then we have discussed about the str length function, that is a part of the loop test. Then how different length function of the string, or how the string will be calculated, or how the number of characters will be calculating of the string, that is done by the str length function. This is the example we have discussed. We have taken lower one as a function, char pointer s, that is taking the pointer variable that is of character type, using one variable, that is I, using the for loop, and this loop will terminate, or this loop will execute until the length of the string, that is the that is done by, or that is calculating by the str length function, that is also executing, and then I++, that is incrementing the values. In the same way, using the lower two, character pointer s, this is the lowercase conversion routines which we have discussed to increase the performance of the program. This is what we have covered with the help of diagrams. We have discussed about this. We also discussed how to convert from lowercase to the uppercase, or uppercase to the lowercase. This is the practice problem. Then we have discussed about another topic, that is how to reduce the procedure code. That is how to reduce different procedure codes that we have discussed or that we have accessed using the procedure, that is reducing the procedure code. As we have seen, procedure code can incur overhead and also become most form of program optimization. So this is whenever we require any procedure, whenever we require any function, so it may cause every time, it may use every time. So it is unusual, or it is very tidy to use the procedure again and again, accessing the elements. So it's better technique to reduce the procedure, that is use the same function, give the output, return the output, and at last uses the again next variable, that is again the function, then uses next procedure, that is you are reducing the procedure counts. This is the example. We have discussed how we have chosen different conditions, that is combine 3. We have used one variable, we use one variable, that is entire length. Then how to eliminate the function call. This is how to eliminate the function call within the loop. Means it is used outside the loop, that is eliminating within the loop. Then we have also discussed another topic, that is how to eliminate unneeded memory references. As there are 4 types of memory, as you know: primary memory, secondary memory, registers, cache memory. So how to fetch the data, or how to input the data and outputting the data from the memory, that is the main motto for increasing the efficiency of the memory. So we have discussed how to eliminate unneeded memory references. Suppose I have taken 4 variables, 4 pointer variables. So that unneeded variable, because I need only one variable that stores the address of another variable. So it is the way, or it is the responsibility of the computer to eliminate the different memory references or eliminate different memory, so that we use only one memory, read the data, write the data from that memory only. So that is where eliminating the unneeded memory references. We will discuss about the program that is in assembly language for multiplication, that is move ss, rbp, xnum, mul, ss, rax, rdx4, xm. Then we have discussed one topic or one program that is written in C language, that have a combine 4 as a function name, return type as a void. These are the arguments, that is v is of vector type, pointer dest, that is of pointer variable, that is of data type, using the variable that is entire. Int length equals to vec length, means calculating the length of the v is used as a string. Then data t, pointer data, uses the pointer variable, that is data t, uses a variable that is get vc start. Then use the ident variable and store the output in the ACC, that is your account variable or accumulator variable. Then using the for loop, that is for I equals to 0, I is less than length, I plus plus, uses ACC, that is your accumulator or accountant, equals to ACC, that is your accumulator OP data I. That is, first of all, it will execute with the help of 0, then 1, then 2, then 3, till the length of the string, that is the calculated by the vec length. Then using the variable that is pointer dest, that is using the pointer variable that stores the address of the account variable, that is it stores the variable address of the account accumulator, that is your accumulated value. This is the accumulated value. Then we have discussed with the help of table, that is combine 1, page number, method, integer type, that is plus minus. In the same way, floating point. So we have taken 2 variables or 2 data types, one is integer, one is floating point. Then this is the diagram, this is the example that is written in the assembly language. Now, today next topic is understanding the modern processor. That is how to understand the multiple processor. That is the next topic. So today I am going to start with your next topic, that is understanding the modern processor. First of all, what is a processor? Processor is a CPU, that is the central processing unit. Up to this point, we have applied optimization that did not rely on any features of the target machine. They simply reduce the overhead of the procedure calls, eliminate the critical optimization problems or the blockers that cause difficulties for optimizing the compiler. So this paragraph or this line said, till now we have discussed the optimization technique for the procedures, for the memory, for the compilers. Now it's a time to work on the modern processor, so that processor will execute or the CPU will execute and perform the task. This says, as we seek to push the performance further, we must consider optimizations that exploit the microarchitecture of the processor. That is the underlying system design by which processor executes instruction. Means we are using the architecture of the CPU so that we analyze the program as well as generate the code for the target processor. To understand ways to improve performance, we require a basic understanding of the microarchitecture. So for applying the understanding for the modern processor, we use the concept, we use the basic understanding or basic overview of the microarchitecture. So due to large number of transistors that can be integrated on a single chip, modern microprocessor employ complex hardware that attempts to maximize program performance. That is, we are using the transistors, we are using the single chip, that is a CPU chip that is used to execute the program to increase the or to maximize the program performance. Now let's see with the help of PPTs what we have covered or what we have discussed till now. This is understanding modern processor. Now candidates, that is students, should be able to understand after teaching this or after learning this, state the purpose of the CPU. That is, what is the purpose of the CPU, why we are using the CPU, or what is the main target of knowing the CPU. Then describe the function of the CPU as fetching and executing instructions stored in the memory. That is the main functionality of the CPU, such as fetching or means fetching the data, executing the data or instruction that is stored in the memory. Then explain how common characteristics of CPU such as clock speed, cache size and number of core affect their performance. So first of all, candidate or the student must be able to understand what is the purpose of the CPU. Then describe the function of the CPU, that is, what is the functionality of the CPU, like fetching the data, executing the instruction that is stored in the memory. Means how CPU fetches the data and how CPU executes the data. Then explain how common characteristics, that is how common qualities or features of CPU such as clock speed, cache size and the number of cores affect their performance. So that is your understanding the modern processor for increasing the program performance. So this is the main crux or this is the main topic that we covered in this slide. Now what is CPU? CPU is the brains of the or the brain of the computer. As I told you, CPU is also known as the brain. Why it is known as the brain? Because it executes each and every instruction. I am repeating again from the first class, as we are a human being, we are using our brain to do any task. In the same way, for doing any task, we require CPU. That's why CPU is known as the brain of the computer system. The purpose of CPU is to carry out program instructions. Means the main motto or the main purpose of the CPU is to carry out, that is to get the program instructions. Each CPU type is designed to understand a specific group of instructions, that is the instruction set. That is, each CPU is designed to understand a specific group of instructions. That is, CPU or the main purpose of CPU is to carry out the program instructions. Our personal computers and small workstations, that is, we are using the desktop, we are using the laptop, that is on personal computers and small workstations. The CPU is housed in a single chip that is known as the microprocessor. So on a personal computer, we are using the CPU that is housed in a single chip that is known as the known as the microprocessor. So CPU is a wider term and microprocessor is a narrower term. Microprocessor includes in CPU. So CPU includes microprocessor. There is a one chip that is available on CPU that is known as the microprocessor. This is your typical modern CPU design showing the pins that connect it onto the motherboard. This is your CPU. As we understand that that box that is attached to the monitor is CPU. No, That is not CPU. We call it a processor, we call it a CPU, but no, there is a small chip, there is a small socket, there is a small pins that is available, that is connected to the motherboard. That contains a microprocessor, or that is known as the CPU. This shows the diagram. There are some pins, these are the pins. Outside there are pins. And then these are the multiple chips. This is shown as the chips, and these are pins. This shows modern processor design showing the pins that connect it to the motherboard. These pins are helping, or these pins are helped to connect to the motherboard, so that it will be connected to the motherboard and get the result, fetches the data, storing the result, and at last giving the output to the user. So this is your diagram for the single chip that is known as microprocessor. Now, next is, what are the components of a typical CPU? Typical CPU means a CPU that requires complex calculations, multiple calculations, that is a typical CPU. There are huge variations in CPU design, means the different computers, different CPUs has different design. So there is a huge variations in the CPU designs, but most will share the following key L component, means these are the following components that is common to the every CPU, but every designing, every architecture of the CPU depends on the architecture to the architecture. What it contains that is common, one is electronic clock. There is a clock that shows the timing in the CPU, in the computer, that is a common element in every CPU. Then control unit, that is your control unit that controls the overall operations of the computer. And this is common, this is available in every computer. Instruction unit means instruction that consists of ALU, arithmetic and logical unit, floating point unit, that is FPU, registers such as the accumulators. These are the multiple instruction units that is available in every CPU, whether they may be different CPU, whether they may be different architectures, but these are available, or these are the common elements. Various buses, means buses are also common in every CPU. Bus management unit, these are the elements that is common to the, or that is available in every CPU, whether it may be a different architecture, whether it may be a same architecture. Now, typical CPU components, means what are the components? First of all, component is clock, that is electronic clock. So now, what is a clock? Electronic clock regulates the rate at which CPU runs and synchronize all the various computer components. This is the most important line. Electronic clock means that is available with the help of computer, that is in E terms, that is electronic clock. That regulates the rate at which the CPU runs, means it is the rate, or it regulates the clock regulates the rate, gives the rate at which the CPU runs, means this gives the performance by which the CPU, that is the central processing unit, runs and synchronize. Synchronize means coordinate among the various computer components. So this is the main topic, or this is the main line, that electronic clock synchronize with the various elements or various components like motherboard, chip, condensers. Electronic clock is helpful for synchronizing with the various computer components. The higher the clock frequency, the more instructions the CPU can execute per second. So if there is a large number of, if there is a high clock frequency, the large number of instructions the CPU can execute per second. The speed of the clock is measured in megahertz. So whenever we say the speed of the CPU, the speed of the RAM, the speed of the capacity, or speed of the computer, that is measured in terms of the gigahertz. In bracket it is mentioned, and therefore the speed of the CPU, means whenever we say speed of the clock, or whenever we say speed of the CPU, that is one and the same thing. So electronic clock synchronizes, CPU runs. The higher the clock frequency, the more instructions the CPU can execute per second, and it is always measured in terms of megahertz. Now, typical CPU component. Next component is your control unit, like this one. What are the components? Electronic clock. Next one is the control unit. Now, we have discussed about the electronic clock. Now, what is control unit? As I told you, it is a nervous system of the computer system. Why it is known as nervous system? Because it controls overall operation of the computer. That's why it is also known as the nervous system. CPU is known as the brain, but CU is known as the nervous system. Why there is a difference? Because CPU can perform each and every instruction, executes each and every instruction, but it does not control the things or controls the other part. But CU controls the other part of the computer. That's why it is known as the nervous system. Like in human body, all the body structure, all the body components are managed by the nervous system. In the same way, all the components are managed, controlled by the CU, that is control unit in the computer system. What are the tasks? The control unit perform the task of, means what are the tasks that is available for control unit? Fetching the instructions from the memory. So first of all, it means control unit fetches the instruction from the memory. Then it decodes the instruction. This is the same cycle which we have discussed in pipelining. Means first of all fetches, then decode the instructions, then manage the execution of the instructions and storing the result. Means managing means first of all take the analysis, depend on the priority of the instruction, execute the first instruction that have a high priority, then next one that has a low priority, then next one that has a different priority. So manage the execution of the instructions, and then at last stores the result. That is stores the result that is after the execution of the instruction. So these are the three tasks, or these are the three common tasks that is done by the control unit. First one is fetching, decoding, then execution. So these are the three common tasks that is available for the control unit. Next, control unit, that is it does this mainly by controlling the links between the other components of the CPU. Why it does this, or why it do so? Because controlling the links between the other components of the CPU. That is the main target for controlling the, or for using the control unit, for controlling the links. It also contains various registers. Means it also there are so many registers that is available in the control unit, such as program counter, that is your PC, that stores the memory address of the next instruction. As I told you, PC always executes or always stores the address of the next instruction. That is, if I'm using 5 instructions, suppose if the third instruction is executing, so PC contains the address of the next instruction, that is your 4th instruction. So that is your program counter. Then another register that is taken by the control unit, that is your current instruction register, which stores the instruction currently being executed. Means we store the instructions that is currently being executed. PC for next instruction, current instruction register for current instruction. So these are the control unit features, or these are the control unit elements that is available for increasing, for enhancing the program performance. Now, next instruction or the next component of the CPU is instruction unit. Our instruction unit consists of ALU. As I told you, what is ALU? It is a arithmetic and logical unit that is used for calculations. What type of calculation? Both the arithmetic as well as the logical calculations. Arithmetic calculations includes plus, minus, divide, multiply. That is addition, subtraction, multiplication, division. As well as the logical operations. Logical calculations includes less than, greater than, less than equals to, greater than equals to. On the integer data, means ALU performs the arithmetic and logical calculations on the integer data that it is linked to. Example of such operations, that is, what are the example which I told you, that is arithmetic and logical operations. First one is your integer arithmetic operations like addition, subtraction. Logical operations, that is add, not, or XOR. So these are the logical operations. Next, the next category of the instruction on unit is floating point unit, that is FPU, which perform math functions on floating point numbers. Means performing the math calculation like less than equals to, greater than equals to, or obtaining the trigonometric sign, that is sin x, cos x, which performs math calculation on floating point numbers, that is non-integer number. So ALU is used for integer variables, integer numbers, that is arithmetic and logical calculations. FPU, that is floating point unit, is used for the non-integer number, that is not in discrete values, that is in fraction values. Instruction unit also consists of various registers. As I told you, there are 5 types of registers: MAR, memory address registers; MBR, memory buffer registers; PC, program counter; AC, accumulator; IR, instruction register. So there are basically 5 types of registers. So instruction unit also consists various registers such as the accumulator, that is used for interacting, or that is used for calculating the instructions, that is interacts with the ALU, stores the result. Which result? Basic result, that is starting result, intermediate result, as well as the ending result. Suppose I am using one formula, that is a board mass formula, right? There is an instruction plus, minus, divide, multiply. So that will be executed one by one. So first of all, one instruction, one operation will perform, that is the first step. That means at first step there is some output that is also stored in the AC. The next step there is some output that is also stored in the AC. Next output also stored in the AC. And at last the final output, one number, that is also stored in the AC, that is your accumulator. So this says various registers such as accumulator that are used while instructions are being executed. So instruction set also includes the registers. So these are the components, or these are the elements of the instruction set, that is ALU, FPU, register. Now, next CPU component is buses, that is how to use, or what is the bus, what is the requirement, how it is useful for the CPU. Buses are set of tiny parallel wires, that is buses are the wires that is used for communicating or interacting or connecting the various components. These are the sets of, sets means there is a group of different wires, tiny parallel wires. That parallel means that is along with, that is more than one wire are used at the same time. That is tiny parallel wires that carry data between CPU components and between the CPU and the external devices and RAM. So that is used for connecting the various components, various CPU components, CPU along with the RAM, that is your memory, external devices like USB cable, USB drive, or the cable that is used to connect with the phone, that is your buses. So buses are the group of different wires that carry data, that is used to sending and receiving the data between the various components of the CPU. What are the various components? Like memory, CU, ALU, and between the CPU and the external devices. Or it may also use to carry data for sending and receiving data between the CPU and the external devices. External devices include pen drives, CD-ROM, floppy disk, as well as the internal devices, that is RAM, random access memory, that is used for connecting with the memory. The three main bus types are, so there are different categories of bus. So the first type of bus is address bus, that is used to carry the addresses of various components, addresses of various memories that are used to set which memory address a CPU component is linked to for read or write operation. So address buses are used to set which memory address, means which of the memory address a CPU component is linked for a read or write operation. Then data buses, that is used to exchange the data between the memory address and the CPU when a read write operation is carried out. That is your data buses. So first of all, address buses, that is used for getting the addresses. Data buses, that is used for exchanging the data between the memory address and the CPU when a read write operation is carried out. Next bus is your control buses. So there are different categories of buses. The three basic or the main category. One is address buses, that is used to set the memory addresses a CPU component is linked. Then data buses, that is used to exchange the data between various elements, between components of the CPU. When read or write, that is reading or writing the operation is carried out. Either we can write or either we can read the data from the memory. Then control buses, that is used to transfer the control command or the command code and return the status signal between components of the CPU and the external devices. So address buses are used for sending and receiving the addresses, data buses for sending and receiving the data, control buses for controlling the various components. Suppose in computer or in CPU, there is a term known as a CU that is used for controlling. So control buses are used in that also for controlling the various components like memory, ALU, CPU. So that is your control buses. The bus management unit, there is a management unit that is known as the bus management unit that manages the transfer of data. That is, there is a management, that is your bus management system or the bus management unit that is used to manage the transfer of data along the external bus connections. That is used for managing the transfer or manage the transfer of data along with the or along the external bus connections. External bus connection means there is a connection with the external or the outside drive or the outside disk, that is your external bus connection. So that is used for managing the data, that means bus management unit, including the links to the RAM. Suppose I am using the CPU or I am using the CU, that is used to connect to the RAM also. That connection or that management is done by the bus management unit. So every management, that is data is transferred successfully, feedback is coming successfully. So all these various opportunities, various feedback, various management is performed by the bus management unit. This is your diagram. These are the level 1 cache. These are the level 1 instruction cache, control unit. These are the data buses. This is internal address and data and control buses. This is internal address, data and control buses. There is a FPU, that is floating point unit. There is a ALU, that is arithmetic and logical unit. There is level 1 cache, that is data cache, instruction cache, level 2 cache. There is a bus management unit that manages all the operations. This is the CPU, that is central processing unit, that contains all these parts. This diagram shows every component of the CPU. This is the diagram that showing the components of the CPU. That is, CPU is central processing unit. Memory buses are used for storing the output. Memory buses are used for giving the output by using various concepts like ALU, FPU. ALU stands for arithmetic and logical unit. FPU stands for floating point unit. In the same way, there is a control unit, there is an instruction cache, there is a data cache. And these are the various buses that is available. One is known as the address bus, data bus, control bus. Address bus is used for memory addresses, that is for using the address. Data bus is used for sending and receiving the data from various registers. Control buses are used for controlling with the help of CU, that is your control unit. Then level 2 cache, this is level 2 cache. There is a bus management unit, that is this is used to manage every component of the bus, for every component of this part. there is the term CPU. These are the external data and control buses. These are the internal. Why these are the internal? That is internal to the bus management unit. So that is internal to the CPU. That's why it is known as the internal buses. If I am using the wires, if I am using the buses outside, that is beyond the CPU, that is known as the external buses, and they are different categories like data, address, control buses. So that is outside, external buses, inside, internal buses. This is the diagram. Next diagram is memory references, L2 cache, L1 cache, floating point unit, that is FPU. There is a ALU also. This is microcode unit, bus unit, execution unit, level 1 instruction cache, memory controller, control generator. This is the diagram for the CPU. We have seen the CPU. There is a CPU, but there is a different parts of the CPU, different components of the CPU. This diagram shows various components of the CPU. Now, what are the functions of CPU? That is how CPU works. That is your functionality of the CPU. The first function is fetch step. That is involving the fetch involves retrieving a binary instruction from a memory address and storing in the address instruction register. Means fetch means for fetching the data, for retrieving the data from the memory address and store in the current instruction register. Why it is stored in current instruction register, not PC? Because the current instruction register stores the address of the current instruction only, while PC stores the address of the next instruction. Next, the memory address of the instruction is stored as a register known as the PC. As I told you, so that CPU can track or keep track of the instruction that is coming to the next. After an instruction is fetched, PC is updated. Why PC is updated? Because the next instruction now becomes a current instruction, and then next to next instruction is updated or loaded into the PC, so that the CPU knows the address of the next instruction it has to fetch. This is the memory address, memory contents. This is the address 10011. These are the contents 1, 2, 3, 4, 5, 6, 7, 8. There are 8 bits. That is your 1 byte or equals to 1 byte. Now, next function is your decode stage. So first is your fetch. Next is your decode stage. That involves identify the operations. That is, identify the various operations that is performed by done by the ALU. That is arithmetic and logical unit. That is opcode, operation code, part of the instruction which tells it which addition or which operation to perform. The operations may be arithmetic operations, subtracting operations, division, multiplication, as well as the logical operations. So decode is used for identifying the operation. If the opcode requires the CPU to act on some data, then the second part of the instruction will contain either the data or the memory address where the data is stored. These are the memory contents. These are the opcode as well as the address. So decode involves the various operations or identifying the opcode as well as the address of the data. Next is your execute stage. So first one is your fetch, then decode, then next is your execute stage or execute step. In this step, the control unit links together the parts of the CPU that are needed to execute the instruction. So execute stage means executing the instructions using the CPU, that is control unit, that is used for linking the various components of the CPU that are mandatory or that are needed to execute the instruction. How it will be done? How control unit links together various operations? This says if the instruction involves arithmetic or logical operations, then the ALU would be connected to the relevant memory location. Some types of instruction also alters the PC, that is program counter, rather than the produce result data. Some instructions also involves an additional write back step if the data is written back to the RAM. So this is your next function, that is your execute stage. Now, CPU characteristics versus CPU performance. First of all, clock speed. Although it might seem that a computer is carried out many tasks simultaneously, the CPU is actually only ever processing one instruction at a time and is constantly switching between the programs. That is, even though it will execute very fast, or it will take many instructions, but it will execute only one instruction at a time. The speed that the processor executes instruction is controlled by the clock speed and measured in the gigahertz. The CPU requires a fixed number of clock cycles. So this is the diagram for the clock cycle. The digital signal from the clock controls the rate that the CPU executes instructions. Summary: the higher the clock speed, the more instructions the CPU can execute per second, resulting in a fast running computer system. Next, cache size. This is also characteristics. Cache size is a small amount of very fast memory that is built into the CPU. Blocks of instructions and data that are used by the CPU are copied from the RAM into the cache. So cache memory is also used as the fastest memory that lies between the CPU and the main memory. If the CPU needs to access a memory address, it first checks the cache memory. As I told you, if the CPU wants some address, so first of all it checks from the cache memory. If the content is available, it takes the data from the cache memory, performs the operations, gives the result. If the content is not available in the cache memory, then go to the main memory, perform the task and give the result. This says if there is, then it accesses the content of the cache bus. So this is the cache memory. This is a data bus, this is your address bus, this is the RAM. So cache memory lies between the CPU, that this is your CPU, and the main memory. And these are the data buses and the address buses that are used to passing the data. As you see with the help of these yellow lines, these are used for passing the data. And this cache memory lies between the CPU and the main memory. That is your RAM. What is the summary? A CPU with larger cache memory, a CPU that have a large number of cache memory and more levels of cache memory will have a high performance than the one without the cache memory. Suppose I have taken the computer, I have taken the laptop, but the cache memory capacity is very small. So that does not give the good speed, that does not give the good bandwidth. But if the cache memory is available, so it will improve the performance of the CPU. Next, number of cores. A multi-core processor, the number of cores means number of instructions, is a single computing component with two or more actual processor known as the core. So processor is known as the core. A dual core processor contains two cores and a quad core processor contains four cores. Each core can process instructions independent of the other core. As I told you, cores means more than one instruction. So that contains, if there are dual core, that is two processor, four cores, the quad core, that is four processor. Each processor is executing their own instruction. The biggest performance gain when using a multi-core processor is when the software has been specifically written on the multiple core. So what is the summary? A multi-core CPU will have a high performance than a single-core CPU with the same clock speed. If there is a speed of the 36 megahertz, let's example, and I am using the multi-core processor, so that gives a more high performance than the using the single-core processor with the same speed, that is 36 megahertz. Now there is a next topic, that is abstract model of processor operation. First of all, let's see with the help of book what we have covered in the slides. This is understanding the modern processor, understanding the computer processor, this is the diagram. as I told you, fetch control, instruction cycle, data cache, addresses, then overall operation that is also performed, instruction cycle, execution unit, EU, pipelining, we have discussed various operations are performed like arithmetic operations, logical operations. What are the registers available? We have discussed with the help of slides. Then functional unit performance, that is how the unit performance will be enhanced or the functional unit can be enhanced. This is addition, integer, single precision, double precision. There is a concept of pipelining is used in this one, throughput, circuit design, latency bound. Then next topic is abstract model. First of all, let's take 5 to 10 minutes break, come back, then starting with the same topic, that is abstract model of the processor operation. So let's take 5 to 10 minutes break, then starting with the next topic. Let's start with next topic, that is abstract model of processor operation. So that is your next topic. This is as a tool for analyzing the performance of machine level program executing on a modern processor. We use a data flow representation of programs. A graphical notation means how to use the graphical notation to express or to represent the various data dependency between the various operations in which they are executed. These constraints then lead to critical paths. That is, then it will become the critical path in the graph, putting a lower bound on the number of clock cycles required to execute a set of machine instructions. That is the abstract model, means showing with the help of the diagrams what is the abstract model of the processor, how the different operations perform with each other, or how different operations performed on a processor. That is an abstract model of data or a processor operation. These are the multiple examples. Now let's see with the help of PPTs. This is an abstract model of processor operation. First of all, what is the computer system component? So this is the abstract model. So if I say abstract model, that does not mean that only a graphical representation. That also means internal parts of the computer, internal part of the processor. That is your abstract model of the processor operations. First one is hardware, that is computer system components. Hardware provides basic computing resources. What are the basic computing resources? CPU, memory, input-output devices. So these are the various computing devices, that is CPU, memory, and that contains or that are a form of hardware. That is we can touch, that is in tangible in nature. We can touch, we can feel, we can execute, or we can use these hardware for the CPU, for the memory, for the input-output device. Next component is the operating system that controls and coordinates the use of hardware among the various application programs. So it is a mediator between the user and the hardware. Next, application programs. There are many applications or resources that are used to compute or that are used to solve the computing problems. For example, if I am using MS Word, that is used for documentation. If I have to present some agenda for the meeting, so that can be prepared by using the MS Word. If I am calculating the salary of the employee, that can be calculated with the help of the another application program, that is MS Excel. So these programs are the way in which various resources, various system resources are used to solve the problem of the users. It may be computing problem, it may be documentation problem, it may be any kind of problem. So it defines the way. Then next component or the next part of the computer system is users, that is we. We as a people, we as a machines, we as a computer. This is the abstract view of the system component. These are the users, user 1, user 2, user 3, there are n number of users. There is a compiler, assembler, text editor, database, system. So one is using the compiler, one is using the assembler, one is using the text editor. There is an application program or there is a system program. For example, MS Office like Word, Excel, PowerPoint. In the same way, database operations like MS Access. Then there is a next layer, or that is the next part is your operating system. That is your intermediate between user and the hardware. Then computer hardware, by which we can touch or with which we can execute the program that is in tangible nature. That is computer hardware. So operating system provides the interface between the user and the hardware. As you see, these are the users, this is the hardware. So there are multiple users, there is a hardware. So how user interact with these hardware? By use of operating system. By use of system software that is known as the operating system. Operating system contains these elements, these application programs like compiler, assembler, text editor, database system. So user interact with these operations, with these programs by the use of computer or by the way of operating system. Then what security goals does operating system provide? Means what is the main motto or what are the advantages of the operating system? The first advantage or the first goal is that it enables multiple users securely share a computer. Suppose I am using 4 computers. So it is the duty of the operating system to ensure that multiple users, multiple receivers, multiple persons uses a secure connection with the computer. Suppose there is only one printer and all the persons of the organization uses the same printer. That is your printer sharing. So it is the goal of the operating system to provide a printer sharing, so that if I am sitting at my desk, take the printout, simply give Control P command, then printout will be arrived. That is separation and sharing of processes, memory, files, devices, etc. What do CIA means? C means confidentiality, I means integrity, A means availability. What is the threat model? How to achieve the security goals? That is the main task, or that is the main goal of the operating system. How to achieve? Memory protection, processor modes, user authentication, file access control. Next goal is that ensure the secure operation is in network operation. Suppose a network is performed. A network means collection of computers. Suppose there are 5 computers that are connected with each other. That makes a network. So it is a responsibility, or it is the main goal of operating system to ensure the secure operation within the network. That is, multiple computers obtain or ensure that there is a secure operation, there is a secure connection among the different processors. In the same way, what do CIA means? What is the threat model? And then how to achieve the security goals? That is done by the authentication, access control, secure communication, logging and auditing, intrusion prevention and detection, recovery. Authentication means, first of all, getting the username as and the password, and then see whether the user is eligible or authenticate or not. If the username and the password matches, then only the web page will come. That is the main task, or that is the main work for the authentication. Means authenticate the user that yes, user is a valid user. It will give the command, it will execute the command. That means user is a legitimate user. It can give the command. It can use the command. Why? Because it is the username and the password are matching. Then access control. That is accessing the control or controlling the access part of the computer. Secure communication, logging and auditing, intrusion, prevention and detection, recovery. Then security is about control sharing. means security is nothing but it is the way to control the sharing part. Suppose I am using printer and the printer is shared by 4 people. So it is a responsibility of the operating system to ensure that security is enabled so that printer will be shared in a customized manner, in a consistent manner. How, why security is control sharing? It ensures separation that may be physical, that may be temporal, that may be logical, that may be cryptographic. OS also needs to ensure the sharing. Reconcile sharing and separation. That is, reconcile means the communication or the connection between the sharing and the separation. Memory protection, that is access control to memory. Next part is the memory protection, that is how to protect the memory. It ensures that user's process cannot access others' memory. That is, if the user has a different process that cannot access the other memory, suppose if a user is accessing the primary memory or the secondary memory, that it ensures that only one user is accessing only one memory. No user is accessing the next memory, cannot access the other's memory. Then the main or the what are the tools available? One is fence, then relocation, base bound registers, segmentation, paging. So these are the multiple techniques by which we ensure that memory is protected. There is an access control to the memory. Next point says operating system and user processes needs to have different privilege. That is, operating system and the user processes, there are let's example 4 processes needs to have different privilege that is available for the operating system for the users. Then CPU modes, what are the CPU modes available? Across processor modes or privilege. Means CPU modes are also known as the processor modes or the privileges that is available in the operating system. So one of the CPU mode is system mode, that is also known as privilege mode, master mode, supervisor mode or kernel mode. Now, what are the features or what are the internal elements of the system mode? First of all, it can execute any instruction. Means the system mode can execute any type of instruction, whether they may be arithmetic operations, they may be logical operations. So it can execute any instruction. Then it means system mode can access any memory location, whether there may be a hardware devices location, hardware location, software location. So it can access any memory location, that is, for example, accessing hardware devices. Then next part is can enable and disable interrupts. That is, it can also enable or disable the interrupts. Interrupts are the disturbing elements that is available in the communication, in the networking. So it can enable and disable the interrupts. Then it can change the privileged processor state. So it means system mode can also help to change the privileged processor state, can access memory management units. Means there are multiple techniques or there are multiple methods for managing the memories like base segmentation, caching. So it can access, that is, system mode can access memory management units also. It can modify registers. It means system mode can modify registers, that is, if I am using the address, that address will be stored always in the MAR, that is memory address register, not the PC, not the MB. So it can modify, or the system mode can modify registers for various descriptor tables. Then next mode is your user mode. Now what are the features of user mode? Access to memory is limited. If I am the user, if I have taken the computer of 2 GB, then it is limited that I am using only 2 GB memory. So it can say access to memory is limited. Cannot execute some instruction. Suppose I am the simple user or the layman user. I don't have authority to execute the database operation. So I am not able to execute some instruction that is of only for available only for administrator. So it cannot execute, or the user mode cannot execute some instructions that have a large number of calculations, large number of computations. Then it cannot disable the interrupts. Like we have studied, the system mode enables the interrupt, disable the interrupt, but it cannot disable the interrupt. Means it is not in the authority of the user to disable the interrupt. It is only authority of the system to disable the, to disable the interrupts. Cannot change arbitrary processor state. Means it cannot change the state of the processor. The processor state may be either ready, running, wait, anything. So it cannot change the state of the processor. Next, it cannot access memory management units. So this is a comparison of the system mode and the user mode. That it cannot access the memory management techniques like page segmentation, documentation, paging. Then next point says transition from user mode to system mode must be done through well-defined gates. That is your system calls. So if there is a changing from the user mode to the system mode, that must be done, or that can be carried out with the various gates that is known as the system code. Means getting the authority of the computer or getting the authority to the user that he or she is able to do each and everything that the system mode performs. That can be done, or that must be done through the well-defined gates that is also known as the system code. That is the system code. Now, what is the system code? It guarded gates from user mode into the kernel mode. Uses a special CPU instruction often known as, or often called as interruption. Transfer control to the predefined entry point in more privileged code allows the more privileged code to specify where it will be entered, as well as important processor state at the time of entry. So system calls uses a separate or the special CPU instructions. What are the special CPU instructions? That follows the instruction, or that controls the instruction, transfer the control to the predefined entry points, allows the privileged code to specify where it will be entered, as well as important processor state at the time of entry. So these are the benefits of using the system call for changing from user mode into the kernel mode, or for changing the user mode into the system mode. The higher privilege code, that is your user mode, by examining the processor state set by the less privileged code or its track, determining what is being requested and whether to allow it. These are the responsibilities of the system code. Now, what is the difference between the kernel space and the user space? They say part of the OS runs in the kernel mode and part of the OS runs in the user mode. That is your half portion runs in the system mode, half portion runs in the user mode. This is also known as the OS kernel. That whenever the OS runs in the kernel, that is known as the OS kernel. Other parts of the OS runs in the user mode, including service programs, that is daemon programs, user applications, etc. They run as the processes. They form the user space. They means the user mode forms the user space on the user land. Difference between kernel mode and the processor running mode is known as the boot, means root. That is the super user or the super user, that is the administrator. So that is the main difference between the user mode and the kernel mode. That is your administrator. If administrator have every authority, then user as a also get the authority if the admin chooses. Suppose if I am using computer, generally there are two types of user accounts. One is administrator, one is your simple user. Administrator have each and every authority, whether to link to the computer, whether to link to the printer. So it will access to the computer only to the admin, such as change the settings of the computer. That is done by the administrator or the supercomputer. But a normal user cannot change the setting of the computer. The main reason is that if everyone is going to change the settings, then how the system will arise or how the system will survive. So this is very important to make the two accounts, that is administrator or super user who have full authority, and the normal user that is only using the system. This is higher level view of kernel space versus user space. That is process 1, process 2, process n. The kernel, hardware, that is your disk, network interface, etc. So the kernel lies between the hardware and the processes. Now coming attractions, user authentication. This is your user authentication. Now let's see with the help of book what we have covered with the help of slides. This is the probability, or this is the scenario that shows that we are using the combined for that takes multiple values for showing the result, whether it may be integer, whether it may be float number. Then from machine level code to the data flow graphs. This is a graphical representation of inner loop code. That is, we are using the program. That is your graphical representation. For a code segment forming a loop, we can classify the registers that are accessed into the 4 categories. There are multiple registers. One is the read-only, then write-only, then local. Read-only includes only the read component that cannot be executed or that cannot be modified. Write-only means we can write the data but we cannot read the data. Local means that is local to the loop. Suppose I am using the variable within the loop, that is local to the loop. This is the diagram for showing the representation of data flow. Then there is a loop that is using the iteration for using the loop. This is the diagram that is showing the computation by the n iterations by the inner loop. This is your critical path, that is cycles per unit, CPE. Other performance factors are CPE, as I told you, of 1.1, lower bound, upper bound, fundamental task. This is the example that is shown with the help of assembly language. These are the practice problems. So next topic is loop unrolling that I have to cover, or I will cover in the next class. Let's see with the help of PPTs. So thank you so much everyone. Now if you have any questions, please text the question, text the doubt. But before that, let's take a quick review what we have covered in the today's class. In today's class, we have continued with chapter number 5, that is optimizing the program performance. First topic is understanding the modern processor. Till now, that is in the last class, we have covered various operations. Various operations means various methods for increasing the program performance. Now, it is the time to understand the modern processor, that is how CPU works, what are the elements, what are the components of the CPU. So that is the main topic. We have covered the purpose of CPU, functions like fetching, executing, various features of the CPU like clock speed, cache size, number of cores that affect the performance. Then we also covered what is the CPU, that is the central processing unit, that is also known as the brain of the computer system. The purpose of the CPU is to carry out the program instructions, to carry out the instructions that will be executed by the CPU. On personal computer, there is a chip that is known as the microprocessor that is available on the personal computer as well as the small computer. This is the modern CPU design showing the pin that is used to connect with the motherboard. Now, what are the components of a typical CPU? These are the components that is common to the every CPU, but every CPU designing is different from the architecture to the architecture. Then, what are the common elements? One of the common elements is electronic clock. Another important common element is control unit. Another common element is instruction unit that consists ALU, FPU, floating point unit, registers, buses, bus management unit. So these are the various common elements that is common to every CPU or every processor. What are the components? First of all, clock that regulates the rate. We have studied about the clock, the measurement in terms of megahertz. In the same way, another component is your control unit that controls the overall operations, that perform the task of fetching, decoding, execution. Various registers also include, that is PC, program counter, control instruction register. Next component is your instruction unit that consists ALU, addition operations, logical operations, and or not, floating point unit that works on the floating point numbers,